Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Okay, my name is Muhammad Zuhairi bin Kasman. Okay, today we will learn about topic 2, Kinematics of Linear Motion. Okay, before we start, kita mesti tahu beberapa some key points that we must know in this chapter. Okay, first velocity. Velocity dia ada tiga, iaitu Instantaneous Velocity, Average Velocity dan Uniform Velocity. Second is acceleration. So acceleration sama juga macam velocity. Kita harus tahu juga tiga, iaitu instantaneous acceleration, average acceleration dan juga uniform velocity. Okay, key point. Okay, instantaneous velocity. Meaning of instantaneous velocity is velocity at a specified position or instant of time along the path of motion. Commonly referred as velocity at point A or velocity at time t. Means dekat sini velocity dia fokus pada satu point. Kalau ni dia velocity at point A or velocity at time t. So maksudnya the focus at time t. So kita tahu formula that we can use to find instantaneous velocity is velocity equal to limit delta s over delta t if delta t equal to approach to 0. So instantaneous velocity ni is a vector quantity, and SI unit that we use for instantaneous velocity is meter per second. Okay, second is average velocity. Okay, average velocity is rate of change of displacement. Okay, if the question want average velocity, we can use this formula. Okay, the formula is average velocity equal to change in displacement in meter over dengan time taken for the change in second. So if we can simplify to this equation, itu delta s over delta t. So vector average velocity sama macam instantaneous velocity, is a vector quantity, and SI unit for this average velocity is meter per second. Okay, now we proceed to how to measure displacement. Okay, from the picture kita tahu displacement distance and displacement, there is difference. Okay, distance kita tahu, kalau kita tengok from this picture pun distance lagi panjang daripada displacement, right? So distance is like a long way, while displacement is just a short way. So from point A to B, kalau distance, it take this blue dash ni to arrive dekat destination dekat B, to point B. So displacement juga from A to B, tapi kita tahu dia red line ni dia hanya singkat, dia take a short way. Okay, dia take short way. So masa yang dia ambil juga, so time taken tu dia akan will be short juga. So distance ni kita tahu dia short a long ways. So memang jarak dia ambil panjang dan masa juga akan panjang. So distance versus displacement. Okay, distance, if a body move from a point A to point D, then the total length of the curved path ABCD red line is called the distance. It's called the distance moved by the body. So kita tengok dari gambar ni, red line ABCD, kita tahu tu adalah distance. While displacement, actual distance moved by a body from a point A to point D in straight line, blue dash. So means kat sini the blue dash, the A toward to point D, dia macam direct terus dia direct terus move ke D. So kita tahu itu adalah displacement. Itu kita tengok pun kat sini short way dia adalah blue dash ni. So difference between distance and displacement. If a body travel a path A, B, C, D and return back to point A after taking another path DA, green. If a body travel then the total distance traveled by the body will be the length of the path A, B, C, D, A. However, its displacement will be 0. The initial and the final points are the same. So dekat sini different dia adalah kita tahu, pada contoh bila object through A, B, C, D and then the returns back to A. So means dekat sini dia adalah total distance. So macam jarak keseluruhan yang diambil oleh body tu will be the length of the path A, B, C, D, A. So dia return back, so kita tahu dia take dia akan jadi total distance. So tapi kalau for displacement pula, dia akan jadi 0 as the initial and the final points are the same. Means dekat sini kita tahu initial point dia A, B, C, D, and then dia return back. Dia pergi ke balik A. So kita tahu initial and final point dia memang sama. Dari sini kita tahu A, first dia A dan last dia A juga kan. So initial dan final point tu sama. So kita tahu displacement dia will be 0. Okay, kita kalau we can tengok, we can see graph displacement again times. So this one for graph displacement against time. So kita tengok slope BE. So kita tahu slope BE this one. So kita tahu bila dia bergerak pada satu tempat, kita tahu slope BE from point B to point A, iaitu displacement dia S1 to S2 at E. So slope at C pula dia lebih refer kepada instantaneous velocity sebab dia fokus pada one point. So dia fokus pada point C. So kita tahu at C kan. So at so bila dia add je kita tahu instantaneous velocity. So kita tahu dia 1 point. So uniform velocity is a motion with constant velocity. So dari gambar ni kita tahu bila dia uniform velocity, acceleration dia automatic jadi 0 sebab dia velocity dia kan constant. So since dia uniform, dia tak ada accelerate sebab dia maintain dia punya velocity. So dari gambar ni, if a particle covered equal distance in equal interval of time, the particle said to be moving with uniform speed. So dekat sini maksud dia bergerak pada uniform speed, time dia bergerak 1.555. So kita tahu dia uniform speed. Okay, dia sebab apa dia 0? Why the acceleration will be 0? Because if we can substitute this value into equation, kalau kita into formula acceleration, we know acceleration, formula of acceleration is v minus u over t, right? So we can assume this one, this initial, so kita assume initial velocity dia 5, while dia punya final velocity dia 5. So when we substitute this value into formula acceleration, which is which is v minus u over t, we know 5 minus 5, so we know will be 0. So we can directly know acceleration will be 0 if the velocity is uniform, uniform. So this one, if we can apply into a graph, so we got this graph. So we know, since so we know if velocity is uniform, we know the shape of the graph this way, the pattern line dia ni. So line dia ni akan be straight horizontal. Okay, dia akan jadi horizontal straight line sebab kita tahu velocity dia maintain in one value of velocity. So kita tahu kalau lepas ni after this we will learn about gradient for each graph. So velocity over time against time. So velocity against time, the graph for gradient for this graph is refer for acceleration. So once this graph is gradient is 0, so we know the acceleration will be 0 too. Okay, instantaneous acceleration. Instantaneous acceleration is acceleration at a particular instant of time. So the formula that we can use is acceleration equal to delta v over delta t, or delta square s over delta t square. Okay, delta v over delta t if the question give us a value of velocity. So if the question give value of velocity, we can find acceleration with differentiate that velocity, and then we get acceleration. But if the question give us displacement value of displacement, we can also to find acceleration. We can also find acceleration with differentiate, but we must differentiate 2 times. So we need to differentiate this one. That's why the formula is d square s over dt square. So means we need to differentiate 2 times. So to find acceleration, if the question give us a value of displacement, but we can find also we can use another alternative, which is if the question give us displacement, we can convert that displacement into velocity first if the question give times 2. So after that we get the value of velocity, so we can differentiate the velocity, and then we got but remember dv over dt ni just for the equation. Okay, if the question give equation for velocity, like velocity equal to t square minus 2t, like that. So change in velocity divided by the time taken to make the change. So change in velocity over time to make the change, delta v over delta d. Okay, uniform acceleration. Uniform acceleration means the acceleration does not depend on time or always constant. So kita tahu uniform acceleration, no change in acceleration occur, so means we know the acceleration will be constant. Okay, velocity change because velocity change in uniform rate. So if we can apply into a graph, kita akan dapat graph yang bentuk macam directly proportional for graph velocity against time. So kita tahu gradient dia macam directly proportional. So since the directly proportional, kita tahu gradient dia akan sama. So since sama, of course acceleration will be constant. A graph velocity against time plot is a straight line whose gradient is equal to acceleration. Velocity is a vector quantity. The change in velocity must thus involve either or both magnitude and direction, and acceleration may due to change in magnitude, change in direction, or change in both speed and direction. Means kat sini kita tahu acceleration velocity and acceleration is a vector quantity. So since the acceleration is a vector quantity, it depends on two things, which are magnitude and direction. If one of these things change, so means acceleration will be changed too. Okay, so the acceleration will be changed too, because it depends on these two things. So change in speed, so acceleration akan berubah, and if change in direction juga dia akan berubah acceleration. So change in both speed lagi berubah. So physical meaning of kinematic linear graph. 3 type kita ada for this subtopic 2.1b. We must know 3 types of graph. First graph is displacement against time graph, second is velocity against time graph, and third is acceleration against time graph. Okay, from this picture we can see I will explain each situation. Okay, I will be explain for each situation. Okay, first situation is object is at rest. So since the object at rest, kita tahu bentuk dia akan like this one, horizontal straight line. Since the straight line, kita tahu kalau displacement, kalau gradient for graph displacement against time, dia represent for velocity. Okay, for this case kita tahu object at rest. So gradient dia, kalau kita tengok sini, gradient dia 0. So since the gradient dia 0, since the gradient dia 0, velocity automatic dari 0. So velocity tak ada. So since velocity is 0, automatically acceleration juga will be 0. So second situation is object is moving in positive direction. Okay, we can see from this graph, object is moving in positive direction. So kita tahu kalau kita from graph this one, from graph displacement against time, dia bentuk directly proportional. Okay, graf dia macam bentuk directly proportional. Since dia macam bentuk straight line, directly proportional ni, kita tahu gradient dia akan constant. Since the gradient dia constant, velocity juga akan constant sebab dia related. So since the velocity dia constant, automatic so kita tahu sini velocity dia 0. Since dia 0, kita tahu kalau untuk velocity against time, gradient dia represent for acceleration. So gradient dia 0, so acceleration dia automatic 0. So third is object is moving in positive direction juga, but dia punya pattern graph tu macam bentuk lain sebab dia ada macam curve sikit. So curve dia lebih kurang macam ke dalam. So since dia ke dalam, kita tahu kalau kita perhatikan sini, gradient dia makin lama makin tinggi. Kita tahu gradient dia makin lama makin high. So gradient dia from low to high. So since dia from low high, kita tahu velocity juga akan increase sebab dia relax. So bila gradient dia makin lama makin so gradient dia decrease. So since dia decrease, velocity juga akan increase. Okay, since kita tahu dia punya gradient increase, gradient velocity dia increase. So bila dia increase in positive direction, kita tahu acceleration dia, kalau kita ada graph ni, kita tahu dia constant. Okay, gradient dia constant. So since dia constant, acceleration akan constant. So fourth is object is moving in positive direction, tapi di ni curve keluar sikit. So dia keluar, kita tengok gradient dia makin lama makin decrease. So since gradient dia decrease, kita tahu velocity juga akan decrease. So kita tahu, tapi still in positive direction. Untuk graph dia pula, if you can see this one dia ke bawah, right? So if dia kita tahu dia downward. Okay, so since dia downward, kita tahu the velocity dia tu, dia macam kita tahu dia punya gradient akan dapat negative value. So since negative value, dia punya acceleration, kita tahu dia akan mengalami deceleration. So bila dia decelerate, kita tahu dia located at below x axis and dekat negative y axis. So kita tahu bila ke bawah dia akan mengalami deceleration. So object is moving in negative or opposite direction. Okay, macam tadi juga, macam tadi, cuma ni case macam the opposite. So object moving negative. So kita tahu negative, dia graph dia bentuk downward untuk displacement against time. So dia ke bawah, kita tahu dia punya velocity dia dia punya velocity ni sama, cuma in negative direction. So that's why bentuk velocity against time, kita tahu dia punya graph horizontal straight line ni terletak dekat below x axis sebab dia in negative direction. So kita tahu dia constant. Okay, v dia ni 0, dia punya gradient dia 0. So since dia 0, acceleration 0. So okay, sekarang is object is moving in negative or opposite direction juga, tapi bentuk graph dia macam melengkung keluar. So since dia keluar, kita tahu gradient dia semakin dia punya gradient increase. Okay, dia dekat sini dia low, so makin bawah dia makin high. So since dia high, kita tahu dia increase. So dia increase, kita tahu dia punya velocity juga akan increase, tapi still lagi in negative direction. So acceleration so since kita tengok graph tu dia constant gradient untuk velocity against time, automatic acceleration akan constant tapi in negative direction. That's why the horizontal straight line located below x axis. So for this case pula, last is object is moving in negative or opposite direction juga, tapi dia punya curve like macam melengkung, curve ke dalam sikit. So dia ke dalam, kita tahu velocity kalau kita tengok makin lama makin low, dia decrease. Okay, bukan high, dia makin decrease. Dia punya gradient from high to low. So since kita tahu gradient dia decrease, automatically velocity juga akan decrease. So kita tahu bentuk graph dia akan macam ke atas. Okay, so since dia decrease, kita tahu bila dia decrease, bentuk graph dia akan bentuk macam ni. So since dia decrease, kita tahu dia mengalami deceleration sebab velocity decrease, dia mengalami deceleration. Dia terletak kalau kita tengok dia terletak located above x-axis kan, sebab kalau kita substitute value untuk gradient velocity against time, kita akan dapat positive value. So that's why horizontal straight line dia dulu terletak dekat atas x-axis ataupun positive axis. Sebab tu dia terletak atas, sebab kita akan dapat yang positive value. Subtopic 2.1c, determine the distance, displacement, velocity and acceleration from appropriate graph. Displacement against time graph. Kita boleh cari for instantaneous velocity. If displacement of against time graph ni, we can find instantaneous velocity. We find gradient of displacement against time graph. Okay, maksud dia kat sini instantaneous velocity ni dia equal to gradient of displacement against time. So kita tahu instantaneous velocity, dia punya formula velocity equal to delta S over delta D. So gradient of dia equal juga to gradient of displacement against time graph. So this one maksud untuk bentuk-bentuk graph for displacement against time. So the first, displacement, the stationary object stay at position X all of the time. Maksud dia kita tahu dia stay, okay, this horizontal straight line. Since the horizontal straight line, kita tahu dia stay in one point. So since dia one point, kita tahu dia macam stop tau, dia macam rest dekat satu point ni. So gradient dia will be 0. So velocity juga akan 0. So this untuk second pula displacement. The gradient of the line give velocity. Uniform constant velocity move the same distance in a given time. The steeper the line, the bigger the gradient, and therefore the greater the velocity. Means dekat sini lagi curam dia punya garis, so lagi tinggi dia punya gradient. Okay, sebabkan gradient dia tinggi, velocity juga akan greater, because kita tahu gradient of the line give the velocity. So uniform or constant velocity move the same distance in a given time. Maksud dia velocity, maksud dia bergerak pada jarak yang sama dalam masa yang diberikan, tapi move in constant velocity. The third is gradient change. So the velocity change is higher when the line is stable. So means kat sini kita tengok the fast to slow, because kita tahu gradient dia kat sini paling high, makin lama makin berkurang. Dia punya gradient makin lama makin decrease. Since dia decrease, kita tahu dia lebih kurang fast to slow. Sebab kita tahu gradient refer for velocity. So kalau makin gradient dia makin steeper, so kita tahu velocity dia fast. So kalau dia kurang dah steeper dia tu, so dia slow, velocity dia slow. Okay, sometimes you may be expected to find the gradient of a straight portion of a curved graph. If this is the case, extend the straight line. Kalau kita boleh extend dia punya straight line tu, so that you can use a large triangle to find the gradient. So dia kalau kita extend kita boleh we can observe clearly lah. We can look more clearly. So displacement, the relative gradients indicates it is moving in the opposite direction, moving backwards, so it finish up where it started. So means kat sini kita tahu dia start from 0. So dia bergerak ke one tempat, dia bergerak ke satu tempat. Bila sampai tempat tu dia kalau negative gradient ni dia indicate macam dia berpatah balik kepada tempat dia yang asal. So means dia returns back to their initial state. Maksudnya dia bergerak kepada dia punya tempat yang dia bermula. Dia start balik kepada, dia return back tempat yang dia start. So tempat start tu juga merupakan dia punya finish untuk dia. Baik, macam kita pergi ke kedai. So dari rumah kita ke kedai, right? So from dari kedai tu juga kita patah balik ke rumah. So kita balik ke tempat yang asal. So velocity against time graph. Okay, velocity against time graph, kita tahu dia punya graph refer, kalau kita nak contoh di question dia nak displacement, tapi if the question give us displacement, a value of displacement, and then the question give us graph velocity or against time, we also can find we also can find displacement of the object with find out dia punya area under the graph. So kalau kat sini area under the graph, dia depends on what shape of the graph or the area under the graph ni. This one like segi empat, ni segi empat, this is triangle and this one is triangle juga. So since kita tahu dia depends on the area under the graph, so kita boleh cari dia punya area. Kalau untuk segi empat sama, area dia wide times by long. So kita tahu panjang darab lebar. Okay, since dia panjang darab lebar, so like ni 15 times by 4. So this one juga triangle. So half times by panjang dia darab dengan ketinggian dia. So half times by 15 times by 6. So sama juga macam ni, half for the triangle. So half times by 15 times by 4. Okay, kita buat we do some exercise. Okay, first exercise first. The figure below show the speed against time graph for a body moving in straight line. Which part of the graph provide evidence that the body is moving with a maximum speed? Okay, first of all we must find out, take out the punya information. Okay, first information yang we can see is this. Kita boleh tengok dia punya what type of the graph. Okay, this graph is the speed against time graph. So kita tahu dia nak maximum speed. Okay, based on from the graph we can see high velocity for this graph is 20, right? So we just take out so we can just take out from the graph the point from the graph. So we can see BC located on the 20 seconds velocity on the 2020. So means ABC merupakan dia punya maximum speed. So determine the maximum acceleration of the body. Saya tak boleh salin sebab ni sebab dia punya tak boleh, saya punya laptop ada problem sikit, tak boleh salin terus sebab nanti hilang. So saya buat dulu. So AB. So determine the maximum acceleration of the body. So dia minta maximum acceleration. So maximum acceleration, macam mana kita, how we want to find acceleration if the question give us velocity against time graph. So it's easy for us to find acceleration but we need to find gradient for this graph first, because we know gradient for this graph represents for acceleration. I had to tell all of you guys. Okay, I have to tell you guys. Acceleration for this gradient is refer for acceleration. Dia minta maximum acceleration. Okay, kat sini kita tengok mana yang rasanya gradient yang paling high. A to B, right? Dia lagi steeper, macam lagi cerun. So kita tahu ini macam lagi tinggi. So since kita tahu dia lagi steeper, kita try cari. So kita tahu juga AB ni merupakan dia punya maximum speed sebab dia accelerate. Kalau kita CD, dia deceleration, right? So DE pun dia deceleration. So kalau BC ni memang dia punya acceleration is 0 sebab dia constant velocity. Since the constant velocity, no acceleration. So kita cari, kita boleh first kita cari, kita guna dia punya rumus gradient. Nak cari gradient y2 minus y1 over dengan t2 x2 minus x1. So kita cari, so dapatlah 20 meter per second square. So determine the average speed of the body for the first 6 seconds. Okay, average the speed, first thing we must find total distance dia. Sebab kan dia minta only for the first 6 seconds, so we put our focus on 0 and to 6 second. Okay, so 0 to 6. Okay, first we must to find the total distance. So how to find? So as we can remember, if we can remember, to find the total distance, we can find the punya area under the graph. Okay, kita boleh cari juga area under the graph sebab dia total distance equal to area under the graph. So area under the graph for this case is kita ini, kalau kita tengok 0 to 6, dia punya area adalah bentuk trapezium, right? So kita boleh guna rumus trapezium to rumus area trapezium to find our distance. So we get 100 meter. So dia minta for the first 6 cycle, right? So total time dia adalah 6 cycle. So average speed yang kita boleh dapat just kita substitute our value of total distance and masuk ke dalam total distance from average speed ini, so 100 meter over 6 cycle. So we get 16.7 meter per second. Actually, we can use another method, or we can use another method to find this area graph. But we must separate. Okay, we must separate like this. You know, this is triangle, and then square, and then we get triangle. So kita boleh sum area. So we can total the area like area of triangle. And then plus area of the square, and then plus area of the triangle juga. So we get sama macam 1,275. So saya kira as intermediate average for the whole journey. So kita boleh cari average speed. Average speed kita boleh juga total distance over total time. So total distance tadi kita dapat 157 meter. So total time yang dia nak tadi 65, right? So the whole journey. So the whole journey for that object is 65. So we just get sum of this is 5 plus 40 plus 20. So we get 24.23 meter per second. Okay, thank you.
Hi and Assalamualaikum. So my name is Muhammad Azmi and I'm from class S15P4 P10. So today we're going to make a quick revision on subtopic 2.2, or as well known as uniformly associated motion. For this subtopic, we are introduced to 3 equations. The first one is V equal to U plus AT, as we always call it as void. And then for the second equation, S is equal to UT plus half AT. And the third one, AT squared. And for the third equation is V squared is equal to U squared plus 2AS. Okay, so where V is the velocity, U is the initial velocity, A is the acceleration, T is the time, and S is the displacement. So we are introduced to these 3 equations, and we are going to take a quick look how to do this, how to solve the problems using this equation. Okay, this is the first question. So from the question, we already know the velocity, the initial velocity, and the displacement. Yes, and we need to find the acceleration or A. So we have to list all the informations given. So the first one is U. So for this question, the U is the U is 245 meter per second. The V is 220 meter per second, and then the S or displacement is 5.5 centimeter, which we need to convert it into meter, and we will get 0.055. Sorry, 0.055 meter. So we need to find the acceleration. So amongst the three equations, so we can use the equation v squared equal to u squared plus 2as. Since we do have the t, so we cannot use the other two equation. Okay, so just substitute, and we need to find the a, so we have to derive a new equation, and we will get a equal to v squared minus u squared over 2s. So we just substitute this, we just substitute the informations into the new equation, and we will get a equal to 220 minus 220 squared, remember there is a squared there, minus 245 squared over 0.055. Okay, so we will get, just press and put it into your calculator, and we will get negative 0.16 exponent 5. The negative sign indicates that it is decelerating. Okay. And then for the, so we just have to put the acceleration in here, the a, just write it. Okay, so a is negative 1.06 to the power of 10 5. Okay, then please remember to put the unit. I'm sorry because I forgot about the unit. The unit is ms to the power of negative 2. Okay, so we have to put the informations that we found out to the a, and then whereas for the second question we are going to need to find the time taken. Okay, so for the second one we need to find the time taken, or the t. Okay, so using the equation void, because actually we can use all the equation, because we need to find the thing, we have to derive a new equation, but to make things easier we're just going to use the void equation. V is equal to u plus at, and then from this we're going to derive a new equation, and we will get t is equal to v minus u over a. So we're just going to substitute all the informations that we've collected. The v here is 220 minus the u is 245 over the a, negative 1.06 times 10 to the power of 5. It is okay to not put the units in the calculation, but the most important thing is to put the unit at the answer. So the final answer will be 2.36 times 10 to the power of negative 4 second. So this is the answer for B. So for this question, we already used two equation, which is the first one, v squared is equal to u squared plus as, and the void one, v is equal to u plus ad. So we need to find another question that use the last equation that we've not used before, which is the SUBTOPIC. Sorry, yeah, but we as a student we actually call it as the SUBTOPIC equation, where s is equal to ut plus half at. So based on the second question, this is the questions. We can see that we can list all the information that we can obtain from the questions. So for the first information, we can see that here it says a stationary airplane. So a stationary airplane, that means the initial velocity, or the u, is actually 0. U is 0 meter per second. Okay, u is 0, and then accelerates at 5 ms to the power of negative 2. So that is the acceleration. A is 5, and travels for 40 seconds. So 40 seconds is the t. 40 seconds. Okay. So the first question asks the minimum length of the runway. So we know that the minimum length is actually the displacement, and we need to find the displacement. So this is why we use the last equation, which is the SUBTOPIC one, whereas s is equal to ut plus half at squared. Since u is 0, we just can cancel out the whole thing at the front, and then we just need to substitute half. A is 5 and 40 to the power of 2, 40 squared, and the final answer will be 4,000 meters. Hence, we know the minimum length for the runway is 4,000 meter minimum length. Okay, so that is the first question, or question B. And now we have to find the velocity of the airplane when it's taking off the runway. So we have the displacement, so we have to list the displacement in the information. S is equal to 4,000 meter. Okay. Okay. And then for the second question, we need to find the v, or the velocity. So with all the information that we've obtained, we just can use the equation void. Okay, so v is equal to u plus at, whereas the v is what we need to find, and then we just substitute 0 plus a is the 5, and the t is the 40 second. Okay, and we will get 200 100 meter per second. So remember to put the unit. The unit is very important, or else even though you're correct, you will not get any marks for it. I think I've covered all the equations and how to use it. And last but not least, I want to wish all of you good luck. And then that's all for me. Thank you and Assalamualaikum.